Hello again. We're starting with graphs of polynomial functions, and I thought it'd be pretty cool to start with the easiest ones, a constant and two examples of a linear polynomial. And as long as you follow this formula, and it's pretty broad, but as long as your leading coefficient isn't equal to 0, in this case 2 is in front of the x, negative 2 is in front of the x, and your n term, your degree, is a non-negative integer, you're fine. I.e., this has an integer of 0 that's non-negative, so it still qualifies as a polynomial. This has an integer of 1, it's degree 1 function, degree 1. The exponent is basically the degree. And as long as you satisfy those conditions, you have a polynomial. So it can be constant, linear, quadratic, cubic, quartic, quintic, etc. This is just a fancy way to write it out. So I've got these three problems up here. And basically what I want to end up doing is talking about zeros, how to find zeros. Real zeros and then complex numbers, imaginary zeros as well. And that's a big step for students. They're not usually very comfortable with it at first, and it is actually very difficult to buy at first, but overall it's not too bad. So here we go. So I've got this example, p of x equals 2. You can just call it f of x equals 2, or you can call it y equals 2. You can call this one y equals 2x, y equals negative 2x if it makes more sense. And basically I'm trying to figure out if the function's even or odd, even or odd, or positive or negative. In this case, this is just a constant function. It doesn't go anywhere, it's staying there, so that's pretty much it. It's just a constant function, that's all you really call it. This one happens to be an odd function, and so does this one. And how do you determine odd function? You look at the degree of the polynomial, or the exponent. So this has an exponent of 1, and this has an exponent of 1 on top of the variable. If it doesn't have a variable, it's a constant function. If it has a 1, a 3, a 5, a 7, a 9, it's an odd function. If the exponent is a 2, a 4, a 6, an 8, etc., it's an even function. Same thing with this one. The other way to tell is this. If the arrows are going in opposite directions, it's odd. If the arrows are going in opposite directions, it's odd. Now, like on a parabola where both arrows will either go up or both arrows will go down, that's an even function because they're going in the same direction. Determine if it's a positive or negative. It's really simple. If the arrow on the right side is going up, it's positive. Or you could just look at the number in front of you could look at the leading coefficient. That's a 2, bam. That's negative, so the function's negative, but the other way to entail that is, see how that happens is that it's going down on the right side. So that's like a very basic introduction, and you're probably already used to it, but you use this to try to gravitate towards more difficult examples, i.e. finding zeros or real roots, and sometimes I use the words roots and zeros interchangeably, and I should be using real roots and zeros interchangeably, and not just roots, because there are complex roots, or i.e. imaginary roots, and I'll end up showing some examples of that later on, and that's where it kind of confuses students initially. But for right now, I hope that helps in terms of a basic introduction of graphs of polynomials. We'll work on quadratics right afterwards. Okay, have a good day for now. Goodbye.